Welcome to my chemistry channel. I want to teach 12th class organic chemistry of CBSE syllabus. Before that, I want to clarify 11th class organic chemistry so that it will be easy to understand 12th class organic chemistry. For that, I named it brief session of 11th class organic chemistry. First, we will see basic concept of organic chemistry. Basic concept of organic chemistry consists of part 1 homologous series, part 2 nomenclature having branch alkene, having functional group and substituted benzene, and third part, that is isomerism. Come to part 1 homologous series. Before coming to homologous series, first we will see what is organic chemistry. Organic chemistry is totally related to organic compounds which are prepared from plants and animals, but nowadays it is known as hydrocarbons. What is hydrocarbon? Means hydrogen and carbons. Hydrocarbons exist due to only two reasons. One is tetravalency of carbon. We know carbon has 4 valency, and second one, self-linkage property of carbon, that is called catenation. That means one carbon atom joins with other carbon atom easily. Then come to points, bonds in organic compounds. Generally, in organic chemistry, the compounds are formed by sigma and pi bonds. For example, you take example methane. In methane, there are 4 sigma bonds are present, and this carbon undergoes sp3 hybridization. So, sp3 hybrid orbital of this carbon overlaps with 1s orbital of hydrogen. So, it forms a sigma bond. Similarly, these 4 bonds are formed by sp3s overlapping. This is the structure of methane. Then come to ethene. Ethene contains 2 carbon atoms, and here each carbon atom undergoes sp2 hybridization. So, sp2 hybrid orbital of this carbon overlaps with 1s orbital of hydrogen, forms a sigma bond. Similarly, these 2 4 bonds are formed by sp2s overlapping, which are sigma bonds. Now come to in middle, there are 2 bonds, and one is sigma, other one is pi. The sigma bond is formed by sp2 hybrid orbital of this carbon and sp2 orbital of this carbon. So it gives a sigma bond, that is sp2 overlapping. And the pi bond is formed by lateral or sidewise overlapping of p orbital of these 2 carbons. And see here, this is py sidewise overlapping, or that is called lateral overlapping, which gives a pi bond having 2 lobes. That means here you can find 4 bonds, that is sp2s overlapping sigma bond, and one between these 2 carbon, the sigma, that is sp2 overlapping. Other one is pi bond, that is lateral overlapping of pp orbital. Then come to ethane. Ethane also contains 2 carbon atoms. Each carbon atom undergoes sp hybridization. sp hybrid orbital of this carbon overlaps with 1s orbital of hydrogen and forms a sigma bond. This side also, the sigma bond is formed by sps overlapping. In middle, we can see 3 bonds are present, where one is sigma bond, that is sp overlapping. That means sp hybrid orbital of this carbon overlaps with sp hybrid orbital of this carbon and forms a sigma bond. And these 2 are pi bonds. These 2 pi bonds are formed by lateral or sidewise overlapping of py and pz. So here you can say these two bonds are sigma, which are formed by SPS overlapping, and in middle one is sigma, which is formed by SPSP overlapping, and now these two are formed by lateral overlapping. Then come to conclusion. Here you can find sp3s overlapping gives sigma, and sp2s overlapping also sigma bond, sps sigma, whereas sp2 sigma, and sp sigma. And now py that is lateral overlapping, which gives pi bond, and pz that lateral overlapping gives also pi bond. Now next is structure of organic compounds, where first point complete structure formula, and second one condensed formula, and third one bond formula. In first complete structure formula, we will write the structure in a expanded way. See here CH4 written in this way, C2H6 written in this way. Then come to condensed structure formula. We will write the structure in a condensed form. See here ethane CH3 and propane CH3 CH2 But when there are CH2 more, just like CH2 4 times, then what to do? Whole bracket CH2 whole 4. If 3 times CH2 whole 3. If there is a branch substituent CH3, then you write here CH3 whole. Similarly, if the Cl is a branch substituent, then you will write Cl whole. That means see here, this is the condensed form of the structure, where CH2 2 times, so whole 2, CH3 is a branch chain, so whole CH3, and Cl also a branch chain, that is your substituent, then it is whole Cl. This is the condensed structure formula, where we will write the structure in a condensed form. Then come to bond formula. In bond formula, we will write the structure in this way. It only indicates bonds. Just like one example here, it is meaning CS3. The straight chain mean only CS3, and there is a joint of two bonds, so this is CS2. Now there is nothing is written here, so this is the indication of CS3 as a substituent, and now here again CS2, and this change indicates CS3. See here CS3, CS2, CH, CS3, again CS2, and this one CS3. Suppose another example where bromine is indicated here, then again see this part is CS3 and this is CH, that means bromine as a substituent, and this is CH2 and this is CH3. Again see here CH3, CHBr, CH2, CH3. This is the bond formula of the structure, these two structures. Then come to three-dimensional structure. Actually, three-dimensional structure also known as Wedge formula. Here two things are indicated, you can see. The solid, this is called solid and this is called dashed. This type of bonds, this is called solid, this is called dashed. What is the meaning of solid and dashed? Now example, just like see here methane. In methane the simple bond indicates, and one is dash form, another is solid form. So what is the indication of these four bonds? If there is a single bond, that means bond in the plane of paper. If there is a solid indicating, then it is known as, that means towards observer. If solid, then towards observer, I can see easily. If there is a dash form, the bond away from observer, that is back side of the structure. Suppose this is a three-dimensional structure where in the plane of paper these two hydrogens, and this is away from observer and this is towards observer. This is your dashed line and here it is a solid one. So it indicates the tetrahedral structure of methane. Then come to Classification of organic compounds. Classification, first point, acyclic or open chain. Acyclic or open chain, that is also known as aliphatic compounds. Aliphatic compounds may be a branch one, may be a straight one. So this is called aliphatic compounds. Then come to second one. So acyclic compounds are called aliphatic compounds. Aliphatic compounds may be straight or branch chain. Let us see one example, CH3CH3. It is known as straight chain, whereas this isobutane, it is a branch compound, branch chain compound, where CH3 group acts as a substituent group. Next come to acyclic or closed ring. That means here the compound is in the form of a closed ring, and two types are present. One is homolytic, another is heterolytic. First come to homolytic. Only carbon atoms are present in a ring, that is called homolytic. Example here, cyclopropane, where you can find 3 carbon atoms are present in a ring, and it is called cyclobutane, where 4 carbon atoms are joined in a ring. Then come to heterolytic. Heterolytic means if other than carbon atom, just like oxygen, sulfur, nitrogen, is present in a closed ring, then it is called heterolytic. Now see this example, here oxygen is other atom, then carbon, and sulfur is also other atom, then carbon, so it is called heterolytic. Then come to aromatic compounds. Aromatic compounds are two types. One is benzenoid compound and second one is non-benzenoid compound. Come to benzenoid. Benzenoid compounds is totally related to benzene and related to it. That means example you can see, this is one benzene, this is aniline. So these are called benzenoid compound. In benzenoid compound, one important property that is called aromaticity it shows, but it will be clear in benzene chapter. Non-benzenoid. Non-benzenoid means there is no benzene ring, but also it shows aromaticity property. That means here there is no benzene ring. You can't find any benzene ring, but it will show aromaticity property. Then come to homologous series. In homologous series, always we observe one member is differ from the next, that is successive member, by a group, that is CH2 group, that is methylene group. So you can find here example, let us in alkane CH4, next member is C2H6, you can find there is a difference of CH2 group. Here also same, there is a difference of CH2 group. In alkene C2H4, then come to C3H6, here also same CH2 group difference, then C2H2 alkyne. In alkyne this is ethine, this is propyne, and there is a difference of one methylene group. In alcohol also same case, there is a difference of CH2 group. Now CH3OH, C2H5OH, methyl alcohol, ethyl alcohol, then propyl alcohol. You can find there is a difference of CH2 group. That means one member to next member, that is called successive members which are differed by a CH2 group. Then come to hydrocarbon. Hydrocarbon means, I told already, hydrocarbon means one hydrogen and carbons. Hydrocarbons are two types. One is saturated hydrocarbon, which contains only single bond. Main example alkane. Then come to hydrocarbons. What is meant by hydrocarbons? I told already, it means hydrogen and carbons. So there are two types of hydrocarbons. One is saturated hydrocarbon and other is unsaturated hydrocarbon. Saturated hydrocarbon means the 4 valency of carbon are satisfied by atoms or group of atoms. See one example here, the carbon is satisfied by 4 hydrogen atoms, and here
4 valency of carbon satisfied by hydrogen and chlorine atoms, and other one is a group of atoms, that is methyl group. The best example, that is alkane, which contains a single bond. Then come to unsaturated hydrocarbon. Unsaturated hydrocarbon means the valency of carbon not satisfied by any atom or group of atoms. That means example is alkene and alkyne. It contains double and triple bond. This is one example ethene, which is alkene, and this is other example ethine, that is your alkyne. Then come to conclusion, hydrocarbons are two types, saturated and unsaturated. Saturated contains single bond, unsaturated contain double or triple bonds. Then come to alkane. Alkane, here you know that contains single bond and whose general formula CnH2n plus 2, where n is one digit, and here you write a structural formula, that is RCS3. What is R? R is the alkyl group or maybe hydrogen atom. So alkyl group, that is R, and what is the formula? CnH2n plus 1. That means one hydrogen atom less than alkane. What is the alkane general formula? CnH2n plus 2. When you remove hydrogen, then it becomes CnH2n plus 1. That is called alkyl group. Take example methyl, and you put a single line, single bond. That means it is a part of the compound. That means any alkyl group is not a compound, it is only a part of the compound. Then it is CH3CH2 ethyl group, CH3CH2CH2 propyl group. Then come to this is isopropyl group. Then come to alkane, where general formula CnH2n plus 2, structural formula RCH3, IUPAC name, that is alkane. I will write here a homologous series up to 3 carbons. So first one CH4, and what is here, when you put R equal to H, then it is CH4, and alkane, what is IUPAC name? Alkane. Since it is only one carbon, so it changes to methane. If 2 carbon, it will be ethane. 3 carbon, it will be propane.
C2H6 CH3 single bond CH3, that is structural formula. And what is IUPAC name? Ethane, because IUPAC name it is known as alkane. C3H8, here CH3, CH2, CH3. Here 2 are different by a CH2 group, and this is known as propane. Then come to alkene, it contains double bond. It also called olefins. General formula CnH2n, structural formula RCH double bond CH2, whereas IUPAC name it is known as alkene. The first homologous series, the compound is C2H4 CH2 double bond CH2, because it contains double bond, and name is ethene. C3H6, here CH3CH double bond CH2 propene. You can check also whether your structural formula is correct or not. Every case here, the carbon should satisfy tetravalency, 4 valency of carbon. That means here you can see this carbon 2, 3, 4. For this carbon, hydrogen is 1, 2, 3, 4. Similarly, 3, 1, 4. That means the structural formula is correct. Alkyne. Alkyne contains triple bond, where the general formula CnH2n minus 2, and structural formula RC triple bond CH, and what is the IUPAC name? Alkyne. First compound, that is C2H2, then structural formula CH triple bond CH, where R equal to H, and what is the IUPAC name? Ethine. Similarly, next member in homologous series C3H4, here CH3 single bond C, triple bond CH and name is propyne. You can find everywhere there is a CH2 unit is different. Functional group. What is meant by functional group? Functional group means here it is an atom or group of atoms which give the characteristics of that compound, just like OH, hydroxyl group, that means it is alcohol. CHO, aldehyde group, that means it is aldehyde. So here functional group means one atom or group of atom which shows the characteristic of that compound. Example, first is hydroxyl group, halogen, X may be chlorine, bromine and iodine. Then come to aldehyde, CHO, Se, COOH, amine, NH2, cyano group, that is C, and isocyano, that is NC.
Now see homologous series having functional group. First haloalkane, where general formula CnH2n plus 1 X, where X is the halogen. It may be chlorine, bromine or iodine. You write in homologous series first general formula, structural formula, common name, IP's name. General formula, it is CnH2n plus 1 X. Structural formula, it is Rx, where R is the alkyl group. Common name, it is alkyl halide, and IP's name, it is haloalkane. The first compound CH3Cl, and it is known as methyl chloride by common name and chloromethane by IP's name. Second one C2H5Cl, you here open it, break it, CH3CH2Cl, that is ethyl chloride, and IP's name chloroethane. C3H7, there are 3 carbons, so it is known as propyl chloride. Prop what mean? That is 3 carbon, chloropropane. Then come to alcohol. Alcohol general formula is CnH2n plus 1 OH. This OH is called hydroxy group, and here general formula CnH2n plus 1 OH. Structural formula ROH, where R is the alkyl group. Common name, it is known as alkyl alcohol. IP's name, it is known as alkanol. So first compound CH3OH, that is called methyl alcohol according to common name, and IP's name, since it is alkanol, it is methanol because it contains only 1 carbon atom. Next compound C2H5OH, you expand it here CH3, CH2OH, ethyl alcohol and ethanol. Eth means 2 carbon, ethanol. C3H7OH, that is CH3, CH2, CH2OH. You see here there are 3 carbon atoms and propyl alcohol by common name because 3 carbon mean propyl alcohol, and propanol because alkanol, here it is known as propanol. Then come to aldehyde. Aldehyde, the structural formula RCHO, where R equal to H maybe or equal to alkyl group. And here structural formula RCHO, if you write in expanded form showing the valency, then it is R single bond C double bond O H, and common name there is no specific you are used, and IP's name it is known as alkanal. The first compound HCHO, HC double bond OH, that means it is known as formaldehyde. According to IP's name, it is alkanal. Since it contains 1 carbon, that is why it is known as methanol. Next compound in aldehyde is CH3CHO. You can write here CH3C double bond OH. By common name, it is known as acetaldehyde By IUPAC name it is known as ethanol. Since IUPAC name is alkanol, so there are 2 carbons, so that is why it is known as ethanol. Third compound CH3CH2CHO, which contain 3 carbons, so it is known as propionaldehyde. In IUPAC name it is propanol. And you can write the structure CH3 CH2 C double bond O single bond H. So IUPAC name is propanol. You can see difference between alcohol and aldehyde by IUPAC name. Alcohol is known as alkanol by IUPAC name, whereas aldehyde is known alkanal by IUPAC name. Then come to ketone. In ketone, the structural formula R single bond C double bond single bond R. Both are, that is alkyl group, they are same. In other form also you can write where R and R dash are different. 2 alkyl groups are different. So come to our structural formula RCOR, and alkyl ketone, that is by common name. In common name it is known as alkyl ketone. IUPAC name it is known as alkanone. IUPAC name it is known as alkanone. Common name it is known as alkyl ketone. Then come to CH3C double bond O single bond CH3. That means 2 methyl groups are present. That is why by common name it is known as dimethyl ketone. And since there are 3 carbon atoms present, that is why it is known as propanone. Alkanone, that means propanone. Then come to CH3 CH2 C double bond O CH3. Totally how many carbons? 1, 2, 3, 4. 4 mean but. But mean butanone. Then here by common name, this side is ethyl group, this side is methyl group. By alphabetically ethyl will come first. That is why ethyl methyl ketone. And what is IUPAC name? Butan-2-one. Then how? Actually this is position 1, this is position 2, and that is why it is known as butan-2 position 2-one. And that nomenclature will clear in nomenclature section. Then come to acid. Acid, the formula RC double bond O single bond OH. That means this is called carboxyl group, where R is maybe H or maybe alkyl group. Let us start structural formula RCOOH, and common name that is referred to aldehyde family. In aldehyde it is known as formaldehyde. Then what you will write in your common name in your essay, it will be clear. Then IUPAC name, that is called alkanoic acid. If 1 carbon methanoic acid, 2 carbon ethanoic acid. Let us start homologous series up to 3 carbons. Here first is HCOOH, where you put R equal to H. HCOOH, that is called formic acid. That means from formaldehyde it is referred, and here it is formic acid. Since 1 carbon atom, so it is called methanoic acid. And now here CH3COOH, there are 2 carbons and it is known as ethanoic acid. And acetic acid that referred to acetaldehyde, common name of aldehyde family. So the 2 carbons, so it is known as ethanoic acid. Then come to 3 carbons, CH3, CH2, COOH. 3 carbons, so that is why in IUPAC name it is known as propanoic acid. Alkanoic acid changes to propanoic acid since there are 3 carbon atoms. Now here propionic acid, it is also referred to our aldehyde, propionaldehyde, it changes to propionic acid. Derivatives of acid. What is meant by derivatives of acid? When the compound derived from acid, that is called derivatives of acid. First example, ester, amide, acid chloride, acid anhydride, like this. Here ester. Structure formula RCOOR or maybe RCOOR dash. Let us see RCOOR dash. The right part always from alcohol, left part from acid. Let us say one example, HCOOCS3. That means this part from acid, this part from alcohol. You can say this is formic acid and this is methyl alcohol. When methyl alcohol and formic acid will combine, it gives this is the ester. When you naming first alkyl part named, after that acid part. Let us see here, this is alcohol part, so the name first methyl, then come to which acid? This one, formic acid, then you will name next this one. Structure formula RCOOR dash, common name that is referred to acid of common name, and IPAC name that is alkyl alkanoate. This alkyl from alcohol part, this alkanoate from acid part. Example HCOOCS3. When you will see this is the ester, it indicates that this is the alcohol part and this is the acid part. When you naming here first alcohol part, that is why methyl, and this is the acid part, that is why formate. Formic acid changes to formate. IPAC name, it is alkyl alkanoate. That means alkyl means methyl, this is methanoate because methanoic acid changes to methanoate. CS3COOCS3, that means this is alcohol part and this is acid part, so methyl acetate. Acetate, that means comes from acetic acid, and ethanoate, that comes from ethanoic acid, so it is methyl ethanoate. Next derivative, that is called amide. Amide, their structure formula RCONH2, common name that also referred to our common name of acid, IPAC name that is alkanamide. If one carbon, methanamide, if two carbon, ethanamide, like this 3 carbon, propanamide. See example HCONH2, it indicates one carbon atom present, so it should be by common name formamide. Formamide means formic acid. Formic acid changes to formamide. Similarly, IPAC name methanoic acid changes to methanamide. CH3CONH2, here 2 carbons present, so referring to 2 carbons, acid is acetic acid, so acetamide, and IPAC name 2 carbon ethanoic acid changes to ethanamide. So here amide means RCONH2, that is the structure formula. If you put R equal to H, HCONH2 formamide, methanamide, similarly 2 carbons, that is ethanamide. Acid chloride. Acid chloride is also a derivative of acid, where OH group of acid is replaced by chlorine. So the structural formula RCOCl, where R may be hydrogen or any alkyl group. Then come to a structural formula RCOCl, and common name which refers to the common name of acid. In IPAC name, that is alkanoyl chloride. Alkanoyl means it comes from the word alkanoic acid, which is the IPAC name of acid. Start first compound HCOCl, only 1 carbon, it indicates it comes from formic acid by common name, so it is known as formyl chloride, and by IPAC name it is known as methanoyl chloride. Methanoyl, that comes from methanoic acid. CH3COCl, it contains 2 carbons. It indicates it comes from acetic acid. So common name is acetyl chloride, and IPAC name is ethanoyl chloride, which comes from ethanoic acid word. Next one is acid anhydride. It is also a derivative of acid, where 2 molecules of acid lose 1 molecule of water and form acid anhydride. So structural formula RCO, which is connected with one oxygen atom, where R may be hydrogen or any alkyl group. Suppose R is H and this R is H, then it indicates it comes from 2 molecules of formic acid. So the common name is formic anhydride. Now in structure formula RCO, which connected with oxygen, the upper part indicates one acid, lower part indicates one acid, and here according to common name, which refers to common name of acid, and IPAC name, that is known as alkanoic anhydride. Alkanoic means that comes from acid, IPAC name of acid. Here there are 2 carbons in the upper part that indicates from acetic acid. In lower part also contains 2 carbon, which also indicates that comes from acetic acid. So the common name is acetic anhydride, and IPAC name is ethanoic anhydride. Here next one is amine, where the structural formula RNH2, where R is only alkyl group but not any hydrogen atom. So structural formula RNH2, where common name alkyl amine, because it contains only alkyl group, that is why alkyl amine is common name, and IPAC name, it is known as alkanamine. Alkane changes to alkanamine. If it is 1 carbon, methanamine. If 2 carbons, then it is ethanamine. So here CH3NH2, where CH3 that is methyl, and so the common name methylamine. And what is IPAC name? Since only 1 carbon, that words comes from alkane, methane, so it is methanamine. CH3CH2NH2, where there are 2 carbons, so and also it is known as ethyl group, so it is ethylamine. And IPAC name, it is ethanamine. Alkanamine, ethanamine. Then last one, ether. Ether, it contains a functional group, that is O, which is called ether functional group, and so the structure formula ROR-, where R and R- may be same or different. Structural formula ROR-, common name, it is dialkyl ether. If both R and R- are same, then it is dialkyl ether. If both are different, it should be named by alphabetic order. Then in IPAC name, it is known as alkoxyalkane. Then how it will be alkoxyalkane? In ether, we will find which one is the long chain. That long chain is named as alkane, and short chain with oxygen, that is named as alkoxy. Let us see here CH3OCH3. Both side CH3 group, this side also CH3 group, so it is known as dimethyl ether by common name. And IPAC, you can say this part as methoxy, and this is only CH3, so it is methane, because it contains both sides same alkyl group, that is methyl, so it is named as methoxymethane. This is the IPAC name. But when we will see CH3OCH2CH3, that means both are not same. One side ethyl group, this side methyl group, and which is the long chain, this side which contain ethyl group, so it acts as a alkane, and the short chain, that is methyl group with oxygen, act as a methoxy or alkoxy. So since it contains here CH3, CH2, CH3, one side is ethyl group and this side methyl group. By common name, it should be named according to basis alphabetic order. So, ethyl, methyl, ether, because ethyl comes first, then methyl, ether. By IUPAC name, it is known as methoxyethane. Why ethane? Because CH2CH3 long chain that acts as a alkane side, and this side CH3O that acts as a alkoxy, and since only one carbon, so it is known as methoxyethane. That means in ether it is very easy, very simple. One side you will take as a alkoxy, other side you will take as a alkane, which is the long chain. In this homologous series, I have explained limit organic compounds, but I will explain in detail when I will teach individual chapters. In coming video, I will explain the rule of nomenclature of organic compounds.